Good day, my dear student, researcher, and market research professional. On my platform, Barefoot Researcher, I like to come with a new topic that is called the correspondence analysis, which is widely used in marketing research. So, my topic today's content is first I will be discussing about what are the basic component of correspondence analysis, right? The nature of correspondence analysis. Then I will be briefly explain what are the key statistics associated with the correspondence analysis, and I will explain all these statistics on steps with a case example. For our class demo today, I case with a case example of 7 mobile brands in India. I compared with the 6 attributes. I will be explaining with that SEO output, what are the output we will be giving. There I will associate with the basis stats, and then finally we will be discussing about the CA plot we call the Y plot. So let us start today's discussion. So what is correspondence analysis? Actually, correspondence analysis is an extension of MDS, multidimensional scaling, and this technique is used for scaling qualitative data in market research, right? So we call it that CA is a combination of factor analysis and multidimensional scale analysis, multidimensional scaling. Why we call the factor analysis? Because this is also used as a dimension reduction. At the same time, why we call the MDS? Because we plot the factor in a two-dimensional plot. Okay, so essentially in that two-dimensional plot we consider it as a row and column variable. So there are a column variable, there are certain brands are there, row certain attributes are there. We try to compare the relationship among them, right? So it could be relationship in the form of similarity, it could be association, it could be interaction, right? For example, right, if we consider row, we can consider as a brands, right? And when we consider as a column, we can call the personality traits. Let's see how it looks like. So this is a table, looks like this. If we consider the personality, this is a personality 1, 2, 3. Those are put in the across column, and when it comes to the brand, it is across row. So I compared 4 brand across 3 personalities. Let us take, right, that row and column, we call it that the biplot. So normally in MDS we call the spatial plot, but here we call the biplot, right? So what we compare, basically we represent row with respect to a given column. That means if I consider 4 brands here, right, it's a Samsung, LG, Sony and Onida. These 4 brands I can compare with respect to one particular, so that personality. It could be fashionable. Same way I can compare 4 brands with respect to autocratic. This is another personality. Okay, and another thing we can represent here, that we can take one column, right, take an example of fashionable, then I can measure how it is related across different brands, right? So comparison can be made between row and columns, considering one fixed column and one at a time, one fixed column and one fixed row. And similarly we can do the relationship among the row and column in a biplot. So now we will come to the basic statistics. There are few basic statistics we need to know while we will be analyzing the output of CA. One is called the correspondence table. This is basically cross tabulation, and we have column and rows, and you can put a number of as I shown the example, number of personality you can put across column, and you can put the brand across row. So this is basically a tabular form. Now the row and column profiles. The row and column profiles, basically we call the cell entries based on the relative cell frequencies. So we will be doing the relative, we have the row total and column total, and then we can measure that for particular cell what is the relative frequency of that cell with respect to the total row and column profile. When we will be explaining with example, that will be more clear. Now mass is a relative frequencies of row and column total. And then we come to the inertia. Inertia is basically the integral of mass times square distance to the centroid. And very importantly, we call the singular value. Singular value is basically the square root of inertia. Just now I show the inertia. If we do the square root of inertia, that basically give you the value of singular value, and it represent the coordination between the row and column score. And we need to have a dimension because we need to plot brands in our example now, or maybe the personality in a two-dimensional plot. For two-dimensional plot, we need to have x coordinate and y coordinate. So this is the scores in each dimension. If I call for the two dimensions, so I can get 4 brands. So 4 brands will have one score for each dimension, so that we can plot in a two-dimensional plot. And finally, we call the biplot. Biplot actually we consider row and column at the same time in a two-dimensional plot, so that we can see how those row and column are associated. In our example, we can consider how the brands are associated with personality. Okay. Now, for our example, we consider 7 brands, and 7 brands is called the Vivo, Samsung, Oppo, Realme, Apple, Xiaomi and Motorola. Now, you know, when we will be purchasing online and offline, we need to compare with the few attributes. So, different people give different level of importance to the attribute. We consider 6 attributes. What are the 6 attributes? Like we compare the brands based on price, value for money, camera quality, then battery life, brand reputation, definitely design and build quality, and finally the performance. So we like to put in a tabular format. Now it is up to you that whether we consider the brand as a column format and row for and row and attributes is a row format, right? So let us see this. So this is our one example data set, right? And this is the empty data set. It's a format, right? What do you see it here? We put brand across column, right? You can see it here. Brands are putting across column, and the 6 attributes are put in the kind of across row. Now this is the one sample form that I like to distribute it to the 50 or 80 respondent. So each respondent will have to give a response to it. What kind of response they will give? So when I give it to you, you may not be ready to give all the responses, but at least for price, you may associate price with Realme or Motorola or maybe Samsung. You can skip the other also. That's why it is mentioned respondents are free to associate each mobile brand with as many as attribute they desire. Okay, and another important, you need to give only yes for each brand for different attribute. So that's why it is called the very much categorical variable. MDS we used, we use the both ordinal data and metric data, but here for the correspondence analysis, it is only the categorical variable. So now I distribute it, 80 respondent, I collect the data. For each respondent, I got this tabular form, and this tabular form that each respondent mark them yes, 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 like someone put price again this, someone put build battery quality again Vivo and Oppo. So when I get the 80 responses, I collect it and I put the summation of all this, like frequency. It comes in the form of frequency. 80 responses. The frequency looks like this table. Table it look like this. So if I read the table, the final table is basically aggregate data. So if I consider price is given yes, price for Realme, that there are 72 years. Price for Vivo, it is a 52 years, right? So this way it's a numerical, it's a kind of frequency. So once I get the 80 responses, I collect it, I generate a aggregate table. So your table will be looking like this after collecting responses from the 80 respondent. But you cannot give the data for analysis onto SPSS using this format. So you have to show the format in a different way. So I will be showing you the how you can do the kind of coding in form of a Excel. So I will bring it to the Excel, then I will take it to the SPSS. So let us do the SPSS. Now you see it here. So this is the table I have shown, right? So this is table is brand across column and attribute across row. These are the filled up form. And now this is the left hand side. You can see I noted this way. This is brand, attribute and frequency. The similar table just I rearrange this way. So here Realme to Apple we put it, and that is compared for a price. So if we consider this, right? If I take this, right? Okay, so if I take this, I copy it, and actually I have to transpose it here, right? So if I do a copy, right, I copy, and then if I transpose it, right, then it will be arranged at 72 to 30, right? So same way Realme to Apple, so I put it all 7 brand for price, then quality, then battery life, then build quality. All 6 attribute are compared against my this 7 brands. So if we look at the another file that is used for the SPSS analysis, this is the file, actually you see it. So this is you can see it that the all 7 brands are compared against the 6 attributes. These are the frequencies are mentioned against this, and this has taken from the main tabular data, what you see it as a table from there. So let us do the SPSS analysis. Okay. Okay, so this is my SPSS file that I already do the import data. So I import the data Excel file, and then it looks like this, right? So I can see it here, the brands, my 7 brands are mentioned over here, and the 6 attributes are placed over here. Each brand is compared against the 6 attributes. These are the frequency. Now my file is ready to do the correspondence analysis. For doing the correspondence analysis, if we go to analyze, and then I go it's as I mentioned, this is the nature of factor analysis, but we are not doing the factor, we are doing the correspondence analysis. So when we do the correspondence analysis, what we see it here, that my brands and attributes are not showing over here. So there are certain problem with my data set. So I need to check my data set. Now let us see how we can identify this. But if you go to the variable, we can see it here that it's a string variable. Brands are string variable, attributes are string valuable, and this is frequencies in numeric. So I cannot use CA for analyzing this kind of data type, right? So this data has to be numeric. But if you look at my data, it's basically a character, so that's why it is called the numeric. So I need to convert it into, means code it in the format numeric variable. So for doing that, I need to the transform. So quickest way, once I do the transform, I do the automatic recode, right? And this is my brands. So I take the brands over here. So I give a new brand name, right here, the new column name, brand. I put it recode. Okay, so when I put the recode, I add new. Once I have the add new, then if I put OK, right, my different column will be created, but that time you see here different. So it is coding is done. So you can see the coding is 1 2 3 4 5 7 brands are there. So coding are placed against each brand, and you can see the numerical coding, you can see it here. Now it become numeric. So I have another variables. This is called the attribute, has to be transformed. For attribute, I need to do another same automatic recode. So I bring it here, I put the attribute over here. Okay, so once I have the attribute, then I give a new name there, attribute recode. So recoding is done. If I say OK, right, and here the lowest value and highest value, if you consider lowest value, it's alphabetically take the starting from A, right? So features name starting with A or B or C, that will be taken as a 1 2 3, right? So I take the lowest value. Once I do it the click, and then it is already coded. You see it's a battery life, starting from A, B comes first, so that's why it take 1 to 6. 6 is already coded, recoded. Now if we look at the data, right, the nature of data, if you go to the variable view, there you can see it, now it is converted into the numeric. So earlier it was brands and attributes were string, now brands recoded and attribute recoded converted into the numeric. Okay, so this part is done. Then what we should do, now there is a another adjustment we need to do, it's a frequency. So when I go to the frequency, this is basically is a that has to be weighted cases. Okay, so weighted cases has to be converted. So for that I go to the data, right, and then the weight cases. When I do the weight cases, I click the weight cases by frequency, right. It's a frequency so that you can compare row and column. Okay, so when I do okay, now you can see it is coming over here, the weight by frequency. So my data set is now ready to do the correspondence analysis. Okay, now if I go to the correspondence analysis, I should able to see all three variables there. Earlier I saw only the frequency, right. Now when you go to the correspondence analysis, you can see here, no, brand record and attribute record, because these two are numeric now. When it comes to the row and column, so look at the this data set, you can see the across. If I go by this, right, if I come to this, right, you can see the brands are across column and attributes are across row. So that's the way we need to decide this. So let me set the data that way. So it is brands are basically across column. So I put it the column, and attributes are across row. Okay. So when I put this, then I have to define this. So how many attributes I have? I have 6 attributes. So I put it 6 attributes. Okay. So update it. So attributes are updated in a range. When I have the brand record, how many brands I have? I have 7 brands. Realme to Apple, right? So I have to put the range. Range starts from 1 to 7. Done. So I put it continue. Now my setup is ready and frequency is already weighted, so that is not a part of any selection here. Now the important thing is that I need to select the model. So what is the model I should have? So I should have, in model I should have 2 dimension. So 2 dimension solution, and this is based where the chi-square, right. So setup is done. So I please OK. Then when it comes to the statistics, I am going for the correspondence table, right, that already discussed. Then I am going for the overview of row points and column points like relative frequency, and then I will be putting in the form of, you know, kind of row plot and column plot on a biplot. So I should have a row profiles and column profiles, both are selected. So we will have one plot for brand and one plot for the attributes. So I do once OK. Then this is very important, the last part is a plot. By default biplot is already selected. Biplot means basically row and column both are taken on the same map. Row means attributes, column means across brands. But I need to have a plot that is called the row plot. Here row plot means across attributes, right? And when I consider column plots, that is across brand. So I need to have this. So once I have this, then I put click. Now my setting is ready for the correspondence analysis. So let us start the analyzing the output variable. So once I say OK, right, my output will be ready for analysis. So this is my output. So if I zoom out, then you can see it here. First is the correspondence table, right? This is basically a frequency table. Here you can see it here that across row, right? Across row you can see the attribute, across column you can see the brands, and these are the votes you get, right? This is similar to this table. I show you the table once, right? This is similar to this table, right? This table, and this correspondence table is generated by the software. Okay. So once I come to my output table, so there you can see this is the active margin. We call the summation of all this row total, right? 20, 51, 23, 64, all summation that leads to 248. Similarly, for the second row, brand reputation, we have 277. It's a row total. Active margin, here is the row total. Now when it comes to the active margin here, 154. This is basically the summation of column total starting from 20, 35, 23, 16, 30, 30, right? And combining row total and your column total, this becomes 1604. So this is called the basic correspondence table. Now come to the row profiles. Okay, row profile is a relative frequency. So how do you calculate row profile? Just I give you one example so that the same thing can be repeated for the other cell. So when I come to the row profile, then I consider only the row profiles, row total, basically row profiles. For that I need to take the row total. So if I consider 20 divided by 248, that becomes 0.081, right? So you can see the relative frequency of battery life for Apple. So that way, if we consider 0.206, how it comes? It comes when we divide 51 divided by 248. So that's the way it computed. Now come to the column. Column will be similarly easy. Okay. So if I consider column total, the first one, right? You can see it 0.130. It can be computed by 20 divided by 154. So it become 0.130. So that's the way to table are computed. Now important thing is the summary. Summary tells you the importance of this correspondence analysis model. In correspondence analysis model, we look at the chi-square and related significance, right? So how to read that? How many dimension you should look for? Dimension is 1, 2, 3, 4, 5, right? And this is called the proportion of inertia. That is, if we consider all this dimension, it is 1. But normally we should look for a minimum of dimension that account 0.60. If we consider one dimension, so my cumulative proportion of inertia is 0.658, this one, right? But one dimension is not meaningful. But if we consider two dimension, my cumulative proportion of inertia is 0.848, this one. So this makes sense. So we are considering the two dimension solution. Okay. Now second point is very important, that how the singular value. What is the singular value? As I mentioned, singular value is basically correlation strain between row and column, right? And singular value can be computed if we do the square root of inertia. Okay. If you do a square root of inertia, then you will get, if you do the square root of this, you will get this value. Okay. And then finally you have total inertia is 0.041. How do you come how to get this one? If you have a chi-square value of 66252, if you divide this 66.252 by total sample value, this total sample is 601604, then you will get the value. It is called the 0.04. Okay. Now it comes to that pointing. Now you need to plot the row points on the map. When you like to go row points, then I need to go with the coordinates. This is called the scores in dimension. So I have 6 attributes, and each attribute has a coordinate value. Okay, on dimension 1 and dimension 2, you see this is called that negative positive values are there, those are put. But very important thing is a contribution across dimension. Now if I consider the contribution of attributes in dimension 1, which one is the highest contribution? You can see it here. Build quality is a highest contribution in dimension 1. If I consider dimension 2, this dimension, which one is the highest contribution? We can see it here. The highest contribution comes from 0.375. This is the build quality. Okay. So you can see the contribution of these attributes are different on different dimension. Okay, that's give you an idea how different attributes are loaded onto the different dimension, like we call the contribution. Same way, if we consider column, how to what are the components are there across columns? There are 7 brands are positioned across column. Now if you read that the dimension, right, scores in dimension will be used for the plot, right, Apple, Motorola to Xiaomi. But important thing is the contribution. So if you look at the contribution, dimension 1, which has सबसे ज़्यादा contribution है, this is called the Samsung. Samsung is 0.475, highest contribution across dimension 1. If we consider dimension 2, which is the highest contribution, Apple is the highest contribution, right? So we measure. That's why correspondence analysis is very good. If you come with a row profiles, and then you can mention which elements in row having contribution highest on dimension 1 and dimension 2. At the same time, if you consider the column points variable across column, you can see which one is loading maximum on dimension 1 and dimension 2. It is something like a item loading in the factor analysis, like the item on a construct, similar concept is used, but it is on a dimension. Now it comes to the plotting. So you get the plotting, and these plottings are based on the attributes that the coordinate you get for dimension 1 and dimension 2. What you should do, you can do click on the map and you can do right. So I put this way, and just for 0 pointer it is coming there. Okay, fine. Then if I put again, then I can have a look here. So I get 0 over here, apply. Okay, now you can see the map over here. The map shows that camera quality comes here across dimension 1, camera quality, price, and this. If we consider the dimension 2, this is called the battery build quality is highest, brand reputation is here, right? This is for the attribute. Okay, now when it comes to the number of brands, so this is the number of brands. Okay, so number of brands we put that way. So this is okay. So I can put again 0. So if I put here again this across this dimension, I can put here 0. So you can see it here, that is Realme comes here, Vivo comes here. So different, this is for the brand wise positioning on the biplot. Now biplot is this one here. Basically this is very important because you get to know the positioning of brand as well as attributes here. So let us have a look. So for that I do the axis positioning first. So come with this, it is 0 positioning already, no issue, it's perfectly fine. Then I put the x-axis right here, it is good. Now what you can see it here, now on the same plot you can see the 7 brands and 6 attributes. So when it comes to the camera quality, right, camera quality, you see Realme and Build, they are very close to the camera quality. When it's to the brand reputation, you see Apple is very close to this. When it comes to the Samsung, right, so Samsung and performance wise they are the best. This is the hypothetical situation, but there is a very camera quality, there is a close competition when Vivo and Realme they are in the close proximity, right? So that's the way you can relate that how different brands are basically positioned with respect to their USP, we call the attributes, right, using the biplot, and this gives many insight. Now I come with another example. If I consider only one attribute at a time, let's say the brand reputation, how the brand reputation for a particular brand reputation, how we can measure the 7 brands. For that I come to my another, I put it in a PowerPoint, I draw the picture because that's for the interpretation. So let us go to the my presentation. Now here on my presentation, so I have taken the plot taken from that SPSS output, and this is specially focusing on the biplot. What you can see it here, okay, here you can see it here the dimension 1 and dimension 2, and here the 6 attributes and 7 brands are plot, and we can see the proximity of brand with respect to different performance criteria, we call that attribute. Now I take one example, that brand reputation is one attribute. I like to compare and compare across 7 brands how the other brands are positioned with respect to brand positioning. So for that what I need to do, this drawing is not nice basically. So I need to draw, this is my brand positioning, circle, and this is my origin. Okay, so I need to draw a straight line passing through brand positioning icon, right, and then the origin. So these straight lines once I draw, then I take the brand. So I take the brand's Apple, I draw a perpendicular line from the Apple point to the straight line. The same way I draw a perpendicular line from Samsung to that straight line. So I get the 7 perpendicular distance and draw from their respective icon to perpendicular, that's the lines, that line represent the brand reputation. Now how I can compare? Now you can see here that the strength it shows, like, and this Apple is very high on brand reputation, right? But when we consider Realme, right, and Vivo, right, how they are compared with respect to the brand reputation. So if we look at the data, right, and the picture, you can see it that I have drawn two perpendicular line from Vivo and Realme to the straight line represent the brand reputation, and the intersection of these two yellow color with the brand reputation, these are very close proximity. So this distance between two perpendicular drop is giving you the insight that how two brands are basically associated or maybe compared with respect to the brand reputation. Now take an example of Realme and Apple. So there is a long distance between the intersection of Apple and Realme's drop, perpendicular drop to this line. So that's the way you can compare how the different brand can be compared with a brand reputation. Same way, if we took a build quality, I take a straight line connecting build qualities dot to the origin, and I can take 7 perpendicular line, right, from that from each brand to that particular straight line, right. So in that case we can measure that how the brands can be compared with respect to particular features. So hope that clear. So in this video I explained that how to conceptualize data, how to format data for SPSS, and using SPSS for correspondence analysis, and how you can interpret the y and x axis, that is called the column and row, and the column and row we can plot on the x and y axis, and you can interpret how the column and row variables are related to each other. You can compare how brands are competing each other with respect to particular performance parameter, and we call that attributes. Hope you find this useful, and I love to see your comments, and that will motivates me to build the next video. Thank you, and welcome. We'll be welcoming you in the next video with the other topic. Thank you for your time.